first thing you notice here is it says the firework is launched from the ground, So that's going to tell me my initial Y position, by the way, at an angle of 75 degrees with an initial speed of 50 meters per second. How long does it take for the firework to return to the ground? So we are looking for time. The word how long tells me I am looking for time. All right? If the only thing I'm looking for is time, I really only need to know my Y velocity, my vertical velocity, because that's what affects how long it's in the air. My vertical velocity puts it up. Gravity is working on it the whole time. Gravity pulls it back down. So I don't even have to calculate my initial horizontal velocity here. So all I have to worry about is my initial Y velocity. And so we're going to use that formula. If you look at your sheet, you have an initial Y velocity formula. That is the initial velocity that they gave me, which is 50 meters per second. And we are multiplying that by the sine of the angle that it was shot at. All right, so this is going to be my initial vertical velocity. Now, it's okay if you always solve for your horizontal velocity and vertical, that's fine, as long as you know which one you have to use. So when I do that, I get approximately, I took it out to 1 decimal place, meters per second. When it's all said and done, I'll do my significant digits, right? But in the process, I take it a little further usually. All right, the other thing that I have to use is the formula that talks about position. So if you look at this, you have a position formula for Y. They said when it hits the ground. So they want to know when is my final position, when is my final Y position equal to 0? When does that happen is the question, right? And so I'm going to take that position function or formula and I'm going to set it equal to 0 because that's what I want to find out. So my initial vertical position, they said from the ground. So my initial position is going to be 0. That's my I there. Plus my initial velocity vertically, I have just calculated. That is my VYI. Time is what I do not know. And then the last part of this will always be the same. This is my gravity piece. So this is my 1/2 G. So that's my G there, okay? So over and over and over, you're going to see this, which means I rewrite these. So when I write these down, this always works out to negative 4.905, okay? So I'm going to rewrite these in standard form. I'm going to write my squared first, but I'm going to go ahead and multiply that 1/2 and that gravity. And that's time squared. Then I'm going to put just the time. Think about a quadratic formula, ax squared plus bx plus c, a quadratic equation. All right. If I had an initial height, I would say plus my initial height. And in that situation, I would use the quadratic formula, right? However, my initial height is 0. I need to know when it goes back to 0. So I need to know when that happens again. I'm really just solving a quadratic here. When the quadratic looks like this, I solve by factoring. The quadratic has a plus constant at the end, I solve with quadratic formula. So here I'm going to solve by factoring. I'm going to factor out that change in time. I actually know the first time that it was on the ground. That's when no seconds had passed, and that's what the math is going to show me. So if I factor out a time here, factor that out, I am left with negative 4.905 and that time plus 48.3. So the math shows me that initially, if I set this equal to 0, one of the times that it was on the ground was at the start, 0 seconds. I need to know the other time. So just like we would do in math class, we're going to take this and set it equal to 0. Negative 4.905 times time plus 48.3 equals 0. You're going to subtract the 48.3, and you are going to divide by the negative 4.905. What do you get? What do you get in two significant digits when you do that? 9.8 seconds. Why is it two significant digits? Let's talk about this. This has 2. This has 2. All right, because we're multiplying stuff, we're going to use the least number of significant digits there. All right, during a physics demonstration, a teacher launches a projectile from the roof of a 20-meter tall building at an angle of 40 degrees and initial speed of 25 meters per second. What's the total time the projectile was in the air? This is the same exact question. The difference is we have a height that is initially taller than the ground, right? And so here's what I'm telling you. You will have your formula sheet, but it repeats itself over and over. If I am just solving for time, I only have to worry about my vertical velocity. So I am going to have to find my initial vertical velocity, taking my initial speed, the sine of my angle here. And I'm going to have to use the quadratic formula. So here's how it's always going to work out for these. You can plug it in. Your initial height, right, is 20 meters. Plus your initial velocity times your time plus 1/2 your gravity times your time squared. Like it's going to do that over and over. The quadratics that's created will also always be the same. It's always going to be negative 4.905. That's 1/2 gravity times time squared. Plus your initial velocity that you just found, 16.1 times time, plus your initial height. In this case, it's 20. So here, I can't just factor. I have to use the quadratic formula. All right? So let's think about the quadratic formula. I'm going to write the whole thing out. I do not write it out every time. You're welcome to if you want to see it before you plug it in, but I don't. But I'll write it out. Quadratic formula here. The quadratic formula is negative b plus or minus the square root of b squared minus 4acl over 2a. So hopefully you all know that. You need to know that. All right, when I put it in, you have a plus or minus, right? So that's a plus or minus in between there. Here's the thing. You are always dividing by 2 times a. Well, what is 2 times a? Gravity. It's gravity. Yes, I'm always dividing by gravity. Does that make sense? And so this bottom number is always going to be that. How does division work? Positive divided by negative gives me a negative. A negative divided by negative gives me a positive. Whether I am 20 meters in the air, right? Or whether I am on the ground, I am going to probably be using that minus. Here's why. We have some teacher that's standing, it is not me, standing on the 20-meter building, right? And they are flinging a projectile off the roof, right? And it's going to the ground. Yes? If I plug this in and if I add here, no matter what happens to this number, even if it doesn't make the whole numerator positive, adding a number, 216, which has to be a positive number, by the way, because it's a square root, will make it go closer to 0. Yes? Closer to 0 divided by negative 9.81. In most cases, it will make it, you'll get a negative potentially, right? Because we're rounding some things. So the first time that it hits the ground, if I were standing on the ground, would be 0. If I'm not standing on the ground, it will look like it happened before time, right? It'll look like back in time it started because this picture is a parabola. And so somewhere it's going to think, oh, well, it started on the ground over here in negative time, right? Since I'm dividing by a negative, I'm actually always going to use, for these problems, a minus there. Because I want the farthest away. I want to know when it hit the ground. And so negative 16 minus a number is going to be a bigger, quote unquote, further away, larger absolute value on top, divided by 9. Does that make sense? So you don't have to do both of them. You literally just have to do the subtraction one for these, okay? And so you can do all of this in your calculator. Do it correctly, all right? So I'm going to write out your calculator steps here for you to do this. So in your calculator, you want to put a parentheses first. Then you want to put your negative b, then minus, then do your square root. Some calculators do a parentheses in your square root. Some do not. So mine doesn't force a parentheses. It just makes me force my way out of the radical, if that makes sense to you. All right. Some require a parentheses. So if there is a parentheses, you can put a parentheses in there. You can do your 16.1, use your square button, meaning use your little x squared. It will square it. It's going to do order of operations. So minus 4, then in your calculator, do your times. Use your negative button, not your minus. Then you're going to put that 4.905. Then your times, and then you're going to put your C. If it required a parentheses in the radical, close that parentheses. If it didn't, you wouldn't have an extra one there. And then you need to get out of the radical and close the entire numerator parentheses. Close your entire numerator parentheses before you divide, or else it may think you're still in that radical. Okay? Here's what we're doing. We're forcing it to do a subtraction before it does a division. Does that make sense? Order of operations would tell your calculator to do division first. You're forcing this subtraction here. So then do your divide. Remember, the numerator is 2a, but 2a in these problems will always just be gravity. You have to put your negative in. Again, use your negative, not your minus. Use your negative and not your minus for your gravity of 9.81. And then you should get a time. All right, what do you get when you do that? So if you do all of that correctly, you should get around 4.24. It keeps going seconds. How many significant digits am I looking for in this problem? I am looking for 2. So that is just going to be 4.2 seconds. That is how long. Look at number 3 together. During a military exercise, an artillery unit fires a shell at an angle of 30 degrees to the horizontal with an initial velocity of 200 meters per second. Assuming no air resistance, how far from the launch point will the shell land? Okay, they did not give me that it was in the air. We're going to assume this guy's sitting on the ground. All right, so because I don't have an initial height, I am not going to have to use the quadratic formula here. All right. So write down what we know. I am saying how far, that is the range. How far horizontally? They're asking how far away. So I need everything here to solve. All right. I need my initial velocity vertically and horizontally. So that's my horizontal. This is my vertical. I need both of those. So I need to figure out my horizontal velocity. That is going to be my initial velocity that they gave me times the cosine of the angle that it was shot at. And then I need my vertical. Initial velocity times the sine. Sine of 30. What's the sine of 30 degrees? So sine of 30, that's an easy one. We don't even need our calculator. It's going to give me 100 meters per second. Square root of 3 over 2, you probably want to use a calculator. For sine of 60, I got around 173 meters per second there for my horizontal. Before we can figure out how far it has gone, we need to know how long it goes that way, right? So the only thing that's going to help us with how long it's traveling is my vertical. So I'm going to go back to that vertical velocity one. This one, however, so it's still the negative 4.905 times squared. That I got from the 1/2 gravity times squared. right? It is then going to be my initial vertical velocity, 100 times my time. I get that from this little guy right here. I'm just rewriting it from my formula. The reason I stopped there is because my initial height or distance off the ground is 0. So in this case, I don't have to add a constant here because I'm sitting on the ground when I shoot it to begin with. I still want to know how long it takes to hit the ground. I'm still looking for time. Okay? Still looking for time here. But for this one, I can factor that time out because I started on the ground. I actually know that one of those happens at 0. I'm looking for when the other one happens. So I'm going to be left with, that's a squared by the way, I'm going to be left with that plus that. And I'm going to set it equal to 0. I'm setting this part equal to 0. So you get negative 100 divided by negative 4.905. How many seconds does it take for it to hit the ground? Yeah, so about 24.4 seconds. However, in this case, they didn't ask me how long it took. They're asking me how far it went. So it traveled at a rate of 173 meters per second vertically for 20.4 seconds. That's going to be my position, my final position. On your formula sheet, it says to add your initial position, but my initial position is 0. So to find this, I'm going to just take that velocity multiplied by that time, and I am going to get a fairly decent number, something like that. How many significant digits does this guy have? He should have 3, which means 1, 2, 3. This is the guy I'm going to look at. How do I write that with 3 significant digits? Round that guy, so he's going to look like that. All right. In an Olympic shot put event, an athlete throws the shot at an angle of 42 degrees to the horizontal with an initial velocity of 14 meters per second. What's the maximum height reached by the shot? I want to point out the logic here because my brain has to see this. Clearly, he did not throw this from the ground if you've ever watched this competition in the Olympics, right? However, we're going to assume the ground. Yes, he probably threw it from down up, so he probably was above the ground. Since they didn't give it to us and it's probably fairly insignificant based on how fast it's going, we're going to assume ground to ground, right? In the real world, he probably was a meter above the ground when he threw this. Does that make sense to everybody? All right, but they didn't give that to us, so we're going to assume ground to ground. Technically, we're going to be a little bit off because of the information we've been given. All right, so in this case, they actually didn't give me initial height. I am not going to need to use the quadratic formula, but they do want maximum height. So we are going to really only, because they're talking about height and we need time, we only have to worry about initial vertical velocity. So I'm going to say initial vertical velocity, once again, 14 times the sine of 42 degrees. I get around that for my vertical velocity. My quadratic is going to, once again, look like this. When you solve for that with factoring, you're going to subtract your 9.37, divide by negative 4.905. Your change in time is approximately 1.91 seconds. For a parabola, parabolas are symmetric. If the entire time to travel from start to finish looks like that, they are symmetric, meaning the highest point happened halfway through that time period. So the highest point happened at a time of 1.91 divided by 2. I kept it out to 3 digits for right now, but exactly halfway through if it was from ground to ground, is when the highest point happened. This equation is the equation for my final position. So if I want to figure out how high was it in the air at 0.955 seconds, I literally plug that in. Negative 4.905, 0.955 squared, plus 9.37, 0.955 is going to give me how high it went in the air. And if you round to significant digits, by the way, it's 2 significant digits, approximately 4.5 meters in the air.